Okay, so now we're talking about internal threads. There you go, took me a while there. Internal threads, which essentially is just like, you buy a nut to go on a threaded component. It's going to screw right onto it, right? Well, internal threads can also be made on projects or on products. So if I can get my little sketcher here to work for me. There we go. So for example, actually let's do this. Let's say that I have a plate of steel right here, and I want to create a threaded hole so that I can just drop we'll say a 5/16 bolt down into it and thread it tight. That's what, instead of actually using a nut, I don't want to use a nut, I want the actual plate to be threaded. So what we need to do is take a look at a section view. Here we go, we're going to do a section view through this of what that looks like. So there we are, and here is the section. We'll draw a real thick plate for us and kind of distort it. So here we go. In theory, there you are. We're going to drill a hole, and then we're going to tap it with the thread system. And if pictorially, it may show up like this. Depends on the software and a lot of other things. So that our bolt can just be screwed right into our plate, and the plate holds it tight. We don't have to use a washer or a nut. So the question is, how do I call out that I want a person to do this? Well, it's pretty easy. It's pretty much the same as calling out the threads, threaded parts. So for example, if this is the hole, I'm going to make a note that says, bam, I want a, 5/16. So I want a 5/16. Move it over just a little bit. I want a 5/16, and we want to do our typical, 5/16 is an 18 pitch, 18 UNC, and -2, what's going to be our letter? B. This way a person knows that we're actually creating internal threads, not an external threaded part. All right, we're not calling out a part number. Now to be fair, most of the time on an assembly drawing, they're just going to kind of draw a bolt, and they're going to list it as a part item to get, and there's not going to be a whole lot of this going on the drawing. They're just going to call it out in the parts list. They're not going to bother showing the note showing the bolt, but they will have to show the note associated with drilling holes and tapping. Now this is not just drilling, this is actually drilling and tapping. Now as far as how do you know what size hole to drill, that's going to be for another chart, where like the one we saw previously, where you're going to look this up and figure out what size drill and tap you're supposed to use. That's not going to be shown to you on the drawing. The final result is going to be shown to you. This is what we want, but it's up to you to actually go drill it correctly. So that's the only real difference, is the actual call out's pretty much the same, except for we change the A to B to imply internal threads. Not too hard to do. Now, as I mentioned, in terms of details, in terms of what you might see on a drawing, and keep in mind this gets changed a lot nowadays that computers are drawing or doing most of our modeling for us. The actual internal thread representation, this would be the top view, this would be a side or all the way through, and this would possibly be the bottom. So you got some top view, you got top view here, and a section view showing how the threads could be shown. And slide down here a little bit. This is what we refer to as simplified, because there's hardly any showing. Now, the actual external versions of bolts, there you go. There's no real threading. Now, the next one, the schematic version, is the one I kind of drew, which is probably the most common. You've got a top view here, you've got an underside that you're looking at with a hidden line possibly shown, and the internal threads are shown there. External is kind of like that. And then if someone wants to really get detailed and show it correctly or more realistically, they may show it like this, where they'll actually show the internal threads with the lines or the edges. This is what it looks like from the top. External kind of looks like this. No one really wants to take the time to do stuff like this because of the fact that, that's just time consuming and doesn't really matter, again, unless you work for a company that specializes in making fasteners. So it's going to be more or less, they're probably going to go with the one above, the schematic. So that's why it's the least commonly used, because who wants to spend the time to do all that detailing? Now, as you're probably fully aware, there are a bunch of different ways that we can design nuts and bolts, and we can actually make them. So for example, we're seeing some cool versions here. You've got some bolts that actually have a square head instead of a hex head. Hex head is pretty common, but square heads are out there too. And you'll notice that they're not actually the full depth the threading doesn't go all the way to the case. Now some types of bolts do. So this kind of thing is one of those things that you'll look up as needed to figure out which type you're looking for, but this is a great little schematic. Now this rounded head bolt that you see here, this is typically used in a lot of different applications where you can't actually latch onto it with a wrench and has a low profile. You've got this one, which is going to be an important one for you to remember, the countersunk, which means the edges are tapered so this falls down flat into a surface. So what we'll actually do is when we drill it, we're going to drill it with a tapered edge so that this head goes down below the surface. That's why we have countersucks. Now we got a step bolt here, which actually has a holding point in this particular case. Scroll down a little bit more. Yeah, I guess more of those there. You don't see those most common. The most common you all are probably going to be dealing with is probably this one, maybe a countersunk. Now, as far as some of the dimensions go, which may or may not matter to you, there are the Hicks head fasteners, like we said, the tapered edges for the countersunk. Different terminology. Not going to spend any time on that one because you can always just look it up on the internet if you don't know what the shape is. And some other kind of things here. Actually, here we have some good different versions of recessors, driving recessors. These are, when it says recess, it means the ability to actually use some type of tool to drive it down inside the part. So for example, a Phillips head screwdriver is a recess because it actually goes into the screw to actually turn the screw. And you'll see a lot of these with like certain types of security bolts where it takes a specific type of driver to be able to turn the bolt or unscrew the bolt, which is a cool thing to think about. And then you got some of these other types of nuts that go on. Obviously your most common is going to be your hex head or your jam nut. Let's see, you got a thicker version right here, some slotted to probably provide more grippage. Let's see, square nut, you don't see that as much anymore. And then of course your machine screw nuts, there you go. But you're probably going to run into these the most. Now again, not too big of a deal for you all because you're not, unless you work at a company that makes these things. But as far as the call outs on a set of plans and what the parts list says you're supposed to get, you should be at least able to generally know that you're dealing with the right part based on what's called out. Now one thing may come up with is, well, how do you determine what the actual bolt length is? How long is this bolt length and this or that? So for example, if I called out a 1/4 inch bolt, how would I tell you how long it's going to be? Well, I might say 1/4 inch, 1/4 inch by 20 UNC 2A, and then I might say 2 inches. Well, what is that 2 inches? Is that the length of thread or not? Well, actually what it is, it's your actual length of buying the thing is going to be the distance from the bearing point to the end. So this is your bearing and this is your tip. So this would be the 2 inches. Now the threads might stop here, but that doesn't mean the bolt is actually based on threads. This is actually your thread length, which to most is not super important. What is important is this right here, so that you can pass through certain materials and still have enough space at the bottom to put a nut and washer on if that's the case, or that it actually goes through material to hit whatever it's going for. So that is your thread length, typically noted at the end of the call out. They may also say like 2L or too long or that kind of thing. Although if you do actually want to know what the thread length is, this value right here is actually something you can calculate. So for standard bolts, it's actually twice the diameter plus a 1/4 inch. So if I'm getting a 2 inch, and this is up to like 6 inches in bolts. So if I'm getting a 2 inch, I'm going to take 2 inches times the diameter of 1/4 plus 1/4. So that would be 2/4. Well, let me do my math over here for you. Here we go. 2/4 plus 1/4 equals 3/4. And you may think, well, that doesn't seem that long, and it's not, because typically we don't need a lot of bearing thread length here. So, and this is of course just an approximation, but if you get a 2 inch, you might just be getting a 3/4 inch worth of of thread, and that varies with whatever type of what type of connector you're using. Some have threads all the way at the top. We're just talking about kind of the standards. Okay, so that's a good stopping point on the on that topic. We've got external, internal. Typically, your callouts, obviously, on your internal stuff, you're not going to end up having a length. I guess you could. They might actually have this little symbol, which means that you're only going to do it for a certain depth. So if you did see this symbol right here and a length after it, that just means that you're only going to drill and tap to a certain depth and stop. If it were a, I should have done this to 2B, that would be internal. They may say like, you know, down 4 inches. I don't know. Who knows? That's the down symbol to let you know that you're only going to do it to a certain length. You're not going to keep going. If they don't provide any of this, means that you go all the way through and keep threading all the way. All right? So that's a good stopping point. We'll see you next.